Singularity Syndicate Episode 4: Semiconductor Chips, Technological Singularity, and India's Rise. Welcome to Singularity Syndicate, the podcast where we dive headfirst into the mind blowing world of artificial intelligence and its transformative impact on future. I'm your host Charita, and this is episode 4, where we are zooming in on the tiny but mighty semiconductor chips, the backbone of AI, automation, and technological singularity. We all, we'll also explore India's meteoric rise from chip importer to global powerhouse and how this ties into race towards future where AI outpaces human intelligence. Buckle up for deep dive into chips, AI, and India's role in shaping the singularity. Let's power up. The technological singularity and chips. The technological singularity is the hypothetical moment where artificial superintelligence surpasses human sparking uncontrollable, exponential tech growth that reshapes civilization. It's a point where predictions break down like a mathematical singularity where models go haywire. But here's the kicker: this future hinges on semiconductor chips. These tiny silicon marvels are the engines driving AI evolution from generative models to autonomous systems. Why chips? Advanced AI like foundational models or reinforcement learning demands insane compute power. Think GPUs and TPUs, optimized for deep learning and packing billions of transistors into nanometer scale designs. The race to singularity depends on chips getting faster and smaller and more efficient, pushing compute per watt into new heights. Without cutting edge semiconductors, the intelligence explosion stays grounded. How semiconductors fuel AI. Let's get technical. Modern chips use 3D stacking, FinFET transistors, and extreme ultraviolet lithography to cram more power into less space. Chiplets, modern modular chip designs boost efficiency by mixing and matching specialized components. AI chip design is now about co-optimizing hardware and software, slashing latency and speeding up data movement. For example, AI overloads need chips like NVIDIA H100 or global TPUs built for matrix math and neural networks. These rely on advanced nodes, think 5 nanometer or 3 nanometer, where transistors are so tiny they are measured in atoms. This tech is critical for the recursive self improvement that could lead to ASI, where machines redesign smarter versions of themselves. Global semiconductor landscape. The global semiconductor market hit $600 billion in 2024 and is on track to smash $1 trillion by 2030, fueled by AI, 5G, IoT, electrical vehicles, high performance computing. Integrated circuits, logic, memory, and mixed signal chips make up 86% of the revenue, while discrete devices like power chips and sensor cover 13%, driven by EVs and smart tech. Mega trends are shaking things up. Electrification of cars, massive data center growth, and 5G, 6G rollouts are stretching supply chains. Geopolitics is pushing into regionalized manufacturing, thick chip sovereignty, as countries like US and EU and India aim to secure their tech futures. India's semiconductor revolution. Now let's talk about India's epic transformation. India's semiconductor market is valued at $52 billion in 2025, projected to double in $103.4 billion by 2030, with a 13% CAGR. Mobile handsets, IT, and industrial applications dominate 70% of the demand, but automotive and IoT are surging. Historically, India imported nearly all of its chips. Imports of ICs, memories, and amplifiers skyrocketed 2000 to 4800% from 2016 to 2024, mostly from China. But that's changing fast. The India Semiconductor Mission, launched in 2021 with 76,000 crore budget, is the game changer. It funds fabrication, design, and ecosystem growth. The production linked incentive scheme sweetens the deal, aiming for 35% of domestic value addition by 2030. Recent wins: 10 major projects across 6 states with over 10 billion invested. Tata Electronics is building a 28 nanometer fab in Gujarat for mobile, EV, and AI chips. Micron $2.75 billion plant in Sanand is churning out LPDDR memory for real-time AI workloads. HCL-Foxconn OSAT facility in Assam and Keynes Semicon Silicon Lab in Karnataka are scaling up. SIC SEM in Odisha is tackling silicon carbide for defense and space. India is also innovating 3D glass packaging boosts power efficiency and domestic sensors. MEM production is feeding IoT demand. The shift to 5 nanometer and 3 nanometer design centers in Noida and Bangalore puts India in the global high performance computing race. India is leveraging its massive STEM talent pool, second only to China. The ISM aims to train 85,000 engineers by 2030 in VLSI design and manufacturing. University industry partnerships like Tata and IIT Gandhinagar are building a skilled workforce. R&D is booming with centers in Bangalore and Hyderabad and Pune focusing on AI-driven chip design and advanced computing. Linking chips, AI and Singularity. Chips are the linchpin of Singularity. AI data centers expanding by 500 megawatt with 10,732 CR in public funding, crave advanced nodes and memory architectures. AI accelerators for cloud and hyperscale systems rely on cutting-edge design. India's public-private partnerships like ISRO and DRDO for defense chips are boosting AI and semiconductor R&D. India's strength, a huge domestic market, strong government backing, and vibrant talent pools challenges. High capital costs, lags in extreme miniaturization, and reliance on imported equipment. But opportunities are massive. Substituting imports could have $2 billion early, and global chip shortages are pushing India to act fast. Global cooperation in India's role. India is not going alone. It is deepening ties with US, China, Taiwan, and EU for tech transfer and supply chain integration. The Semicon India platform is drawing global players like Micron, Applied Materials, and TSMC, positioning India as a trusted partner. Digital sovereignty and national security are driving these alliances, especially as chips become critical for defense, space, and AI. Companies and technologies powering the shift. Who's leading the charge? Tata Electronics is building India's first 28 nanometer fab with, with Taiwan's PSMC. Micron technology is scaling up in Gujarat for memory chips. HCL, Foxconn, and Keynes Semicon are tackling OSAT and silicon fabs. Globally, NVIDIA and AMD drive AI chip innovation while TSMC sets the standard for advanced nodes. Software-wise, TensorFlow and PyTorch power AI chip design, optimizing neural networks. Cadence and Synopsys provide EDA tools for chip layout. Graph neural networks via PyTorch, geometric mapped supply chains, Tesseract OCR extract data from shipping dogs. AWS IoT Core integrates real-time sensors data for smart chips. Outlook. India's semiconductor journey is a rocket launch from chip consumer to global chip maker. By 2030, India would claim 10% of the 1 trillion global market, powering AI, autonomy, and march towards singularity. Challenges like high cost and IP game gaps remain, but the foundation is solid. Semiconductors are the fuel for singularity fire, and India's stake is becoming indispensable. That's episode 4 of Singularity Syndicate. If you're fired up to dive deeper, I can share a system architecture for an AI chip design platform, a GitHub repo for semiconductor simulations, or a pitch deck to fund the chip startup. Let's tune in. Thanks for tuning in. Share this with your tech crew. Stay tuned for more. I'm Charita and this is Singularity Syndicate. Keep pushing for the future.